Let's do vector triple product. How to determine the vector triple product of three vectors A, B, and C. If I have three vectors A, B, and C, the vector triple product of A, B, and C is A cross B cross C, like this. It is the cross product of A with the cross product of B and C. Now, take note, this is not equal to A cross B cross C. So, this is what we are doing and not this, except the question specifies in this order. So, if I have A, B, and C, and I want to do the vector triple product of A, B, and C, I'll simply do this. Okay, now watch. I'll be showing you a shortcut after this first procedure. So watch to the end. If I have these three vectors, I'll remember how to calculate for cross product of vectors. In cross product of vectors, the determinant approach is what we normally use. First of all, I'll do the cross product of B and C first. Then I'll take that cross product with A and determine the cross product of A and the result of the cross product of B and C. You get me now? So let me do B cross C first. For B cross C, it is the determinant of this. We have the first row, I, J, and K. The coefficient of I for B and C, we have 1, we have 3. We have 1, we have 3. For J, we have -2, we have 1. We have -2, we have 1. For K, we have 2, we have 3. 2, we have 3. Okay, let's determine the determinant of this matrix. For the determinant of a 3 by 3 matrix, you know how we do it. If we are expanding along the first row, this I has a plus, that's the place sign. J has a minus, K has a plus, and it alternates. So we are expanding across the first row, we use I, J, and K. So if I pick I, close up, okay, let me use the determinant approach. Close up this column of I, close up this row of I, we have -2, 2, 1, 3. -2, 2, 1, 3. J has a minus. Close up this row of J, this second column rather. Close up this first row. So we're having 1, 2, 3, 3. 1, 2, 3, 3. Then for K has a plus. Close up this column of K. Close up this row of K. We'll be having 1 -2, 3, 1. 1 -2, 3, 1. There's a video for cross product of vectors you can watch. Okay, so this is it. We have I. This is, initially we had a 3 by 3 matrix, but now we've broken down the matrix into 2 by 2. So for 2 by 2 matrices, the determinant is simple. Multiply the two elements on the principal diagonal minus multiply the two elements on the other diagonal. So -2 times 3 is -6. Minus 1 times 2 is 2. Then we have minus J. 1 times 3 is 3. Minus 3 times 2 is 6. Then we have plus K. 1 times 1 is 1. Minus 3 times -2 is -6. So you have -6. This is I into, okay, let's go straight. -6 minus 2 is -8. Times I minus 8I. 3 minus 6 is -3. Times minus J is plus 3J. 1 minus 6, that's 1 plus 6, which is 7, times K, that's 7K. So this is the vector B cross C, the cross product of B and C. So we will now combine this with A, we'll now take the cross product of A and this particular vector. This is A. So I'll simply say A cross B cross C is the cross product of this vector 2I plus 3J plus K and this other vector minus 8i plus 3j plus 7k. Let's go straight using the same approach, determinant approach. This is it. We have I, we have j, we have k. So for I, we have 2, we have minus 8. For j, we have 3, we have 3 also, 3, 3. For k, we have 1, 7. If I expand along this first row, I with a plus, close this column, close this row, we have 3, 1, 3, 7. 3, 1, 3, 7. J has a minus. We have close this column, close this row, we have 2, 1, minus 8, 7. 2, 1, minus 8, 7. K has a plus, plus K. Close this column and close this row. We have 2, 3, minus 8, 3. 2, 3, minus 8, 3. So let's multiply. This is I into 3 times 7 is 21. 3 times 1 is 3. 2 times 7 is 14. 8 minus 8 times 1 is minus 8. So that will be plus 8. This is 6. This will give me minus 24, right? 3 times 8 is 24. So if I just say plus 24 because of the two minuses. 21 minus 18. That will be 21 minus 3, sorry, is 18. So we have 18i. 14 plus 8 is 22, right? Yes. So that's minus 22j. 6 plus 24 is 30. So this is 30k. And this gives the vector triple product of A, B, and C. All right. Let me show you the short way to do this. Maybe it's not necessarily or really a short way, but you will not have to go through the hassle of doing determinants of 3 by 3 matrix. What have I done? Oh God. Let me write this matrix A, pardon. Let me do this. Okay. This is B, this is C. A is this, right? Yes. So A is 2i plus 3j plus k. So for vector triple product, it is equal to the dot product of A and C times the vector B minus the dot product of A and B times the vector C. That's it. So let's do this and see if we're going to get this answer. Remember how to do dot product. Let's do A dot C. The dot product of A and C, first of all, is this. This is A, this is C. So I'll be doing 2 times 3, that's 6. 3 times 1, are you there? 3 times 1, that's 3. 1, which is the coefficient of k, 1 times 3 is 3. That's how to do dot product. Multiply respective coefficient. 6 plus 3 is 12. So this is 12. Alright, let's do the dot product of A and B. For A and B, A dot B, it is this. 2 times 1, which is 2. 3 times minus 2, which is minus 6. 1 times 2 is 2. Okay. 2 plus 2 is 4. 4 minus 6 is minus 2. That's the dot product of A and B. So, for vector triple product, we are doing A dot C times the vector B minus A dot B times the vector C. So, let's do this now. This is A dot C into B minus A dot B into C is equal to the vector. What's A dot C? A dot C is 12. So 12 multiply the vector B. Vector B is I minus 2j plus 2k. I minus 2j plus 2k minus, what's A dot B? Minus 2. Into what's the vector C? 3i plus j plus 3k. 3i plus j plus 3k. 12 times I, 12i. 12 times minus 2 minus 24j. 12 times 2, that's 24, so we have 24k. First of all, minus will give me a plus. So I have plus 2 times 3i, that's 6i, plus 2 times j, that's 2j, plus 2 times 3k, that's 6k. Let's collect like terms. I, 12i plus 6i, what's it? 18i. Are we there? 20 minus 24 plus 2. Minus 24 plus 2 is minus 22 actually. So we have minus 22j. And 24k plus 6k, that will give us what? 30k. Boom, we are there. So this is it for this particular video. Subscribe, like, and share this video to your friends and your classmates.